We had superb presentations. I learned a lot. I think everybody did. So the last section is going to be on writing specific.
Can I see my screen?
Not yet. Started.
Okay.
I mean, here we go. Now we can see it.
You got it?
Yeah.
Okay.
So we thank Dr. Sandhickham for leading this. Again, this is optional, but I hope people want to stay. How to take your basic science research to the next level, writing hypotheses at specific aims.
Okay. Just it's looping. Okay. Okay, so what is a hypothesis? A hypothesis is a statement that introduces a research question and proposition an expected result. It's important to propose a hypothesis-driven research with well-defined and feasible specific aims. A strong hypothesis should be well-focused and testable by the specific aims and experiments. A testable hypothesis is an integrated statement that needs to offer a clear introduction to a specific experiment, its intentions, and the possible outcomes. A testable hypothesis is a hypothesis that can be proved or disproved as a result of experimentation. Hypothesis is based on your past and preliminary studies and published literature. And beware of concepts that can't be strongly supported with your own preliminary data or published data from other laboratories. Now, it's very important to know that the specific aims section is the most important of the application. The specific aims constitute the template or master plan for the rest of the research plan. The aim section should include everything about an application that is important and exciting without the detail. And limiting your application to a few specific aims keeps you clear of the very common mistake of being overly ambitious. The opening sentence must be an interest-grabbing sentence that immediately establishes the relevance of the proposal to human health. And it should introduce what is missing in your aims, that identify the gap in knowledge. It is the gap in knowledge that is holding back the field and is what you would like to address in the application. The specific aim section must summarize the general impact of the expected outcomes. The positive impact statement should make clear that collectively the outcomes will advance your field of research. So let's talk about our working hypothesis 1. Nicotine plus high-fat diet-induced hepatic steatosis is mediated by excess free fatty acid delivery from adipose tissue lipolysis coupled with inactivation of AMP-activated protein kinase. Now, to test this hypothesis, we proposed M1 designed to investigate whether exacerbation of hepatic steatosis in high-fat diet-fed mice by nicotine is associated with the inactivation of AMPK. We carried out Western blot analysis to test the phosphorylation state of AMPK in liver lysates. And second was designed to determine whether excess free fatty acid delivery from adipose tissue lipolysis is obligatory for nicotine and high-fat diet-induced hepatic steatosis by using ACP-MOX, a specific inhibitor of lipolysis. So our rationale are steatosis, the hallmark feature of NFLT, can occur as a result of excess free fatty acid delivery from lipolysis of adipose tissue, increased de novo lipogenesis, and reduced fat oxidation, and export in the form of very low density lipoproteins. And we predict that similar mechanisms are also responsible for high-fat diet plus nicotine-induced hepatic steatosis. And AMPK, a central regulator of cellular energy homeostasis, plays an important role in fatty acid, plays an important role in fatty acid metabolism through its ability to regulate the key fatty acid biosynthetic pathways. So to test the hypothesis, male C57 black 6 mice were fed either a normal chow diet or a high-fat diet with 60% of calories derived from fat. Mice on either diet received twice daily IP injections of nicotine, 0.75 milligram per kilogram body weight or saline for 10 weeks. And to determine whether nicotine-induced abdominal fat lipolysis mediated the ectopic fat deposition in the liver, additional groups of mice on a high-fat diet were given nicotine or saline in the presence or absence of SCP-MOX in the drinking water for 10 weeks.
Amia,
Yes.
can we give them time to write their own specific aims?
I will be summarizing. Yeah, maybe they can do.
That's the main purpose of the session. I
Oh.
want just to give, I mean, I think you did a great job so far of showing what the specific aims are. Now I don't think you have to show the data. I think we want them to have time.
Let's see. So because this is important for the data is showing, okay, I can go for this one.
Right, that's not right. But the purpose here is to get them to write specific aims and hypothesis. So you don't need to show your data. It's nice data, of course.
No, I mean, here I'm showing that this is the IJ, this is NCD, this is SCP-MOX, this is a high-fat diet. So I was proving that the hypothesis, how we came into this hypothesis. So is it all right?
I would just let them start writing specific aims.
Okay.
I think he gave a good background. I think the important things with specific aims and hypothesis is to make sure, if you can make them causal, try to show.
So let me get a little bit, okay.
Yeah.
So first of all, those data is prove our working hypothesis that nicotine plus high-fat diet induced hepatic steatosis is mediated by inactivation of AMPK and excess-free fatty acid delivery into the circulation from adipose tissue lipolysis. Because if you give SCP-MOX, you stop adipose tissue lipolysis and you stop hepatic steatosis. So this is our working hypothesis too. This is what we are showing again. And I will show you that how you do that, how you prove also causality. So we found that particularly this compound, PNU 282987, specific alpha-7 nicotinic acetylcholine receptor agonist, actually restores AMPK. So our hypothesis was, is it possible that restoration of AMPK by this compound, PNU, ameliorates nicotine plus high-fat diet-induced hepatic steatosis? So that is our aim, to define if restoration of AMPK by PNU protects nicotine plus high-fat diet-induced hepatic steatosis. So this is again the design that male mice were fed NCD or high-fat diet with 60% of calories derived from fat and received twice daily IP injections of nicotine, PNU and PNU plus nicotine. So this data just show that, look at this part, this is high-fat diet, this is PNU, and look what happened. PNU completely significantly prevent the nicotine plus high-fat diet-induced apoptosis. And if you look at this data, that PNU also restores phospho-AMPK and SHART1 levels. So this means, but again, you need to prove the causality. So we know that to test the hypothesis that AMPK activation is obligatory for nicotine plus high-fat diet-induced hepatic steatosis by treating mice with ICAR and AMPK agonist. So again, to determine whether AMPK activation is needed for nicotine plus high-fat diet-induced hepatic steatosis by treating mice with ICAR. So this rationale, this experiment based on our earlier studies, where we have shown that IP injections of nicotine when combined with a high-fat diet, causes hepatic steatosis through inactivation of AMPK. And we also shown that PNU reduced nicotine plus high-fat diet-induced hepatic steatosis by improving AMPK signaling. But these are all associations. To show causality, we will use the AMPK agonist ICA to restore hepatic phospho-AMPK levels to determine if it reverses nicotine plus high-fat diet-induced hepatic steatosis. And so this is our experimental design to determine whether inactivation of AMPK is obligatory for nicotine plus high-fat diet-induced steatosis. Additional groups of male mice on a high-fat diet will receive twice daily injections of nicotine or saline in the presence or absence of AMPK agonist ICA. And the ICA dose we used is based on the results of a previous study that used this dose to enhance running endurance in sedentary mice. So what will be the expected outcome? So this study will provide the most powerful and unequivocal information on the causal role of AMPK in high-fat diet plus nicotine-induced hepatic steatosis. Finding prevention or attenuation of liver pathology in nicotine-treated mice by ICAR would constitute a strong evidence for a pivotal role of AMPK in nicotine plus high-fat diet-induced hepatic steatosis. So then I will just
let's have people let's have people write their specific aims. Sorry.
Yes.
Sorry,
one second. I need to show one second.
No, let's do it now.
Okay.
We're okay. Sorry, I wasn't clear to you, Amia. So if people in the trainees can make up either a PowerPoint or a Word, one hypothesis and one specific aim, you can do it based on your research or research you heard today. We'll give people maybe 5 minutes and then we'll share it. I think that was sort of what I'm sorry I wasn't clear, but that's
I didn't know.
Yeah.
Dr.
So
Friedman?
yes.
But one thing I need to.
Yes, Christina.
Oh, it was me.
Oh, Anna?
Oh, I have a question.
Yes.
So I've always been kind of confused about the difference between hypothesis and prediction. And is it okay to use a prediction in like specific aims as opposed to a hypothesis?
These are the more generalized term, most commonly used term that hypothesis. I think, more or less similar to predictions.
Yeah, I think most people use hypothesis.
Right, exactly.
And then you sort of have your null hypothesis, or you say
null hypothesis.
Right. You want to compare things. I think it's very important.
Right.
Most of our research, some people do this qualitative research, but I think most of the people that I'm encouraging our trainees to do would be quantitative research that you say A is going to work better than B, or, so nicotine compared to saline leads to hepatic steatosis. That's your hypothesis. And then you aim to prove it by, giving mice nicotine, and then you have knockout mice to show that it's involved in the nicotine receptor and to show that it's going through AMPK. You use ICAR. So you want to show in your aims sort of causality if you can.
Right. Something is also very important because I did show you that nicotine plus high-fat diet actually causes hepatic steatosis through fatty acid delivery as well as AMPK inactivation. But in our e-cigarette study, what we have shown, we want to see that maybe same signaling pathway is operating. But we found that nicotine delivered through e-cigarettes causes hepatic steatosis, so which is supportive of our earlier hypothesis. But what we have found that is disproving our second hypothesis is not mediated by AMPK. So in fact, AMPK signaling is completely, it's not present there. So it is done by perturbations of some other things, for example, circadian rhythm, for example, BML1 gene. So it's needed. It could be tested, could be disproved. So we cannot generalize. It has to be based on your experiment.
So I opened it up that anybody can share when they want. If any, we can give people a couple more minutes. But if anybody wants to start getting ready here to share their screen of an aim and a hypothesis and an aim. Everybody working on it? We have Magda on the participation. Thank you, Magda. Do you want to comment a little bit about how you use, sort of statistical methods to make sure your aims are quantitative while people are starting to write? How are people doing? Are they writing?
Dr. Freeman, would it be easier to just put our responses in the chat?
That would be good too, yeah.
Okay.
You want to? The advantage of doing it on the PowerPoint or Word is then you sort of can keep it. You might want to look back on this, way down the road. Either way. Okay, the first one.
ELA inhibition prior to choice will attenuate preference for?
BLA is bilateral adrenalectomy, or what's BLA?
Sorry, it's basolateral amygdala.
Okay.
Oh,
I guess-
I just
choice.
took something from my grant and put it
good.
in here.
Okay.
Yeah, will attenuate preference for punished reward, whereas inhibition during the pre-punishment delay will increase choice of delayed punishment by disrupting punishment expectation.
And then your aim manipulating.
Delayed punishment discounting via optogenic inhibition of IOFC and BLA.
It's lateral orbitofrontal cortex and basolateral amygdala.
So you sort of have a compounded hypothesis.
I
think
did
that-
because
I think
my
that's
aim
discouraged.
for my grant was
Right.
a little complex,
Right,
but
so
that was the
I-
only one I thought of on the fly.
Right. So I would, it's good, very good. So I would break that into two hypotheses, hypothesis 1A and 1B or so. BLA
Okay.
inhibition prior to choice will attenuate preference for punish reward compared to controls or sham operated mice. So you want to have, either or in your hypothesis. And then hypothesis.
Sorry, I left out part of my hypothesis. I'll put it as part B
Okay.
real quick.
I think this looks good, but only a little large. I mean, if you can make it a little shorter
Right. It's also not quantitative though.
and focused.
So
It
this is
will be
by-
quantitative because we measure behavior, and we'll be also be looking at neuronal firings.
Mhm.
So we will have quantitative data for that. I couldn't really fit all of that
Right.
into this
Okay.
short time.
Yeah, not much time, definitely. Okay. Anybody else want to give us a try? Laura? Syed? Simran? There we go. Jose? Lipolysis is essential for electronic induced cardiac dysfunction in mice. Good.
Yep.
Okay.
I would add also adipose tissue lipolysis.
Oh, I'd have to specify that.
Yeah.
Okay.
But it looks good.
Now, this is not quantitative, though. Use RNA to compare. Oh, it's okay. Yeah.
Regulated genes between mice.
I
Yeah.
think that's okay. You know, I would
Yeah.
maybe do it e-cigarettes as tested by by RNA-seq. E-cigarettes in mice treated with Acipamox will have reversal of genes induced by e-cigarettes alone or e-cigarettes plus placebo.
Yeah, it's something like that.
Right.
Because that's what we found with this RNA-seq, this Dr. Hassan's paper, that these particularly is not mediated by MPK signaling. This is mediated by disruption of circadian rhythm gene and also inflammation. So, but SCP-MOX, we didn't study that paper. We didn't do that, but this is good. That it's like first part needs little bit aim, little bit need to focus. RNA-seq to compare differentially regulated genes between mice chronically treated with e-cigarettes and e-cigarette. Yeah, a little bit rewording. I mean, writing a little bit differently.
Got it. And I should mention the reversal, right? Correct?
Yeah.
Okay.
I mean, that shows causality, that something
Mhm.
is blocked by the changes in genes are blocked by Acipamox.
Right, because that's what I was showing, because if I could have completed, I would give a little bit of better window.
Mhm.
And my talk I designed just for 30 minutes, so that, like, when you use SCP-MOX and you are preventing adipose, you are preventing hepatic steatosis. So that means clearly you are showing that adipose tissue lipolysis is essential for e-cigarette induced hepatic steatosis.
Okay. Got it.
Anybody else want to try? Simran, Syed, Tim? Candace? Angela, go ahead. Guys, don't be shy.
Sorry, I'm just trying to piece my hypothesis
Okay.
together.
Right.
Um,
Okay.
yeah.
Yeah, maybe I stopped prematurely. It would have helped them if I completed my talk.
Sorry. I mean, you can go ahead. Sorry about that.
No, it's fine. I'm done.
Okay. I did want to give them an opportunity to think about this and break.
Yeah, I mean, you have 45 minutes, so my planned almost just 30 minutes, and then so that they can have.
Right. Anybody else want more time or want to show us something? Otherwise, we can end a little early. Okay, Christina, do you want to announce the feedback and the next events?
Yeah. I was just talking, but I realized I was on mute. Yeah, I was going to put the link to the evaluation in the chat. So if everybody could please fill out the evaluation, it's really, really quick. It really helps us give feedback, helps us make these sessions better. Yeah, so your feedback is very helpful, and we try to apply it to the next institute. So for example, for our first institute, somebody said that they wanted more time for discussion in breakout rooms, which is why we had that time built in the beginning. I mean, earlier before Dr. Sinha Hakim's talk. So yeah, so if you could please fill out the eval, again, we would really, really appreciate it. And our next event is next Friday, where we have a drug legalization panel. We will have some amazing speakers lined up, and I mentioned them before, but they will be, it'll be Dr. Bo Kilmer from RAND. We'll have Dr. Martin Iguchi, Dr. Linda Richter from Partnership to End Drug Addiction, and then Joseph Friedman, and they'll all be speaking about the legalization of hard drugs and the pros and cons, and this is pertaining to the law change that just happened in Oregon. So additionally, after next week, I believe the following event after that is we have a presentation by our own Dr. Juanita Booker-Vons for substance use in communities. So we will have that on March 12th. So that's that. And so for that one, we have Dr. Booker-Vons, we have her brother Ted Booker, who's with the Mott Institute, Dr. Jovita Murillo, who is faculty at Charles Drew University, and we have two other potential speakers who we're waiting to get confirmation from. So we're really excited about both of those upcoming Friday afternoon seminars. They're from 3 to 5 p.m. You will see them going out in the blasts via the CDU broadcasting. And yeah, if you would like to attend, please go ahead and click on the link. And our institute is April 16th, and the topic is clinical, epidemiological, and behavioral skill development. So we have some really awesome speakers lined up for that one as well. So we hope that everybody will be able to attend. And yeah, I'll leave the link up in the chat for a little while. In case anybody would like to hang out and still needs to complete the eval. And also, if everyone saw, Dr. Evans found the link to the video, and he put that in the chat as well, if you scroll a little bit up. So yeah, so that's it. That's all I got.
Okay, great job, Christina. Thank you for organizing this. And thanks everybody for
Yeah,
coming.
thank you, Christina. It's a great job.
It was really
Thank
good.
you.
Thanks everybody for participating. We'll see you guys at next events.
Thank you all. See you.
Bye.
Bye.
Thank you. Bye.
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 Bye, Max.
Thank you.
Yeah.
Bye.